Hello and good day to everyone. My name is Muhammad Yazid bin Muhammad Sufyan, and today we will be presenting about the post-shutdown uh, from TURCOMP as a contractor to Petronas. Let me begin by introducing the company, which is TURCOMP Engineering Services Sendirian Berhad. It is a Malaysian engineering solution provider established to support a critical provider establishment such as oil and gas, petrochemical, power generation, and water treatment. With the headquarters in Malaysia, Turcom has grown into a reputable name in shutdown or turnaround services, mechanical works, and technical manpower supply. The core services by Turcom is plant turnaround and maintenance, industrial equipment and automation solutions, and also supplying skilled engineering and maintenance personnel. Uh, Turcom is built on strong corporate values, which is innovation, customer satisfaction, and an international vision which guide every project that they undertake. So as for the Turcom's beginning, Turcom was founded in 1992 in Labuan, Malaysia. The name Turcom stands for turbine and compressor, that's the name, highlighting the early specialization in rotating equipment maintenance for process and power plants. It started as a small service provider in Labuan. Turcom has grown into a full spectrum engineering company with a national presence, operating 15 offices, 9 workshops, and 5 warehouses across all major cities in Malaysia. The expansion is driven by the commitment to quality, reliability, and a deep understanding of client needs in highly demanding industrial environment. As for our main focus here, which is our case study on Turcom at Petronas Chemical Methanol Sendirian Berhad at Plant 1, which is at Labuan. So take a look at the case study that demonstrates Turcom capabilities in the commissioning of Petronas Chemical Methanol. Turcom was engaged as the key contractor to help commissioning and modernize the plant. The main goal was to maximize the reliability, safety, and operational efficiency at the plant. They were responsible for mechanical completion, which is MC, and pre-commissioning, which is included inspection and documentation, walkdowns and punch list clearing, loop tests and system energization, safety checks and client support during the commissioning. Turcom also deployed a skilled multidisciplinary uh, team covering mechanical, electrical, instrumentation, and commissioning roles. The team executed over 300 system walkdowns with more than 2,000 loop checks and closely uh, supervise coordination with the vendors for the equipment energization and testing. Uh, what did Turcom achieve from this contract is they completed the commissioning support ahead of the schedule. They also maintained zero lost time injury, showing their commitment to safety. They cleared 98% of the punch items on time and also played a major role in preparing the plant for safe and compliant operation in safety. That is all for me. I will pass it to the next presenter. Thank you.
Hello, my name is Aklingan. Today I will present the plant shutdown workflow based on our company is TURCOMP. This workflow is essential to ensure the safety and efficient and cost-effective plant shutdown and restart the process. This is our flowchart. Before we go to plant shutdown, We must prepare this thing because this thing is very important for our company. Need to start a shutdown to avoid any mistake or cause that happen our company. The first thing we must do is shut down any station first. This start when they need like a schedule turnaround, equipment failure, or a safety concern. Shutdown memo is a preparing, raise assessor, and change the review under the management of a chain, or short name is MOC process. The second step we must take is planning phase to define the scope and resources and schedule for shutdown. Uh, Before we planning, we must prepare a scope of work, WBS, and then resources planning, shutdown, master schedule, cost limitation. This pressure is the team plan everything in detail. The scope of work is defined and a special force is formed. Risk assessment like OSOP are done to like accept and reprogram are used to make a schedule and track the work. Before we start a shutdown plan, the thing that we must do is preparation. All this thing is to make sure that all logistics, safety, and material are placed before we do a shutdown. The thing that we must have is equipment material, uh, contractor employment, and documentation and permit. And then the last one is SAE preparation or faulting is this we must do before we start our shutdown. The fourth one is shutdown equation fascia. To carry out shutdown work safely and efficiently but planned times. This is a question show shutdown work. The plane is safely solid and depressurizing. Equipment is open, cleaning, repairing, and replacing. And inspection are done following a standard like IP and NDT. And then we also daily meeting ahead to track the progress and cost and safety. Number five is post-shutdown activity. To safely return the plant to operation on good conditions. Let me explain this thing. After the repair and everything assembling, leak tests and equipment check are done. And then come commissioning, checking instrument, utility, and engineering the system. Once it's ready, the plant is handed back to operation. The last step is post shutdown review, where we capture the strength and weakness and opportunity for improve. For after the shutdown and review is done to lead from the process, safety, schedule, budget, and repair quality e- evaluator. All report is complete to be safe.
Assalamualaikum and hello everyone. In this section, I will present about post-shutdown report. P1TA17, a project focused on plant asset rejuvenation, PAR1, for Plan 1. The executive summary indicates the project achieved successful completion and first production on May 7th, 2021. A notable point is the 5-day delay in mechanical day, primarily attributed to the R101 refractory upgrade. The report highlights valuable lessons learned in planning integration, resource loading, and scope management, crucial for future turnaround. From the project overview, we understand P1TA17 was the 17th turnaround for PC Methanol Plan 1, executed by Turcom Engineering Services Sendirian Berhad. The initial scope involved 246 worklist items, predominantly piping, control valve, and static equipment. Despite four worklist scope changes and nine deletions during execution, strong 95% of 10 worklists were completed, indicating effective project control in adapting to changes while maintaining high completion rates. The worklist summary visually reinforces this success, showing 95% executed worklist with only 1% scope changes and 4% related worklist. This metric suggests efficient management of project scope and execution. However, the schedule and HSC performance section reveals critical challenges. Integrated planning was significantly delayed by 33 days, largely due to CMCO, impact on site activities, and data gathering. Pre-execution also saw a 5-day delay, and the critical shutdown to startup phase was prolonged by 15 days. The mechanical day delay of 5 days is noted in the executive summary, was indeed driven by R101 refractory upgrade. This delay underscored the impact of external factor and critical path. Despite schedule pressures, the HSC commitment was high priority. Lagging indicators show only four total cases recorded, with 002 rules violation and near miss dangerous occurrences, which is commendable safety record for a project of this scale and complexity. Strong engagement in proactive safety measure, as highlighted by leading indicator, clearly contributed to this positive outcome. Analyzing the cost summary, the total estimated contract sum was RM 22,430 and 380 ringgit Malaysia. The cost distribution by phase reveals significant investment in LOA2, execution manpower, equipment, HSC tools, scaffolding, prefabrication, RCP services at over RM 13.5 million, indicating the labor and equipment intensive nature of the project. LOA3, execution, blasting, painting, PMT, and inside to machining also represented a substantial cost at over RM 2.9 million. The cost distribution by project area provides further insight. Hyper accounted for largest share at approximately 43.3 percentage, emphasizing piping replacement and related items as the primary cost driver. E103 and R101 followed at 20.9 percentage and 10.8 percentage respectively, highlighting the substantial financial commitment specific equipment upgrades. The key lessons learned and recommendation section is perhaps the most critical for future project improvement. Under resource management, the issue of insufficient QA/QC and painting blasting personnel at peak times points to a need for more robust resource loading and fatigue management strategies. This is a common challenge in large-scale turnarounds, and optimizing this can prevent bottleneck. Planning and integration suffered from challenges in worklist handover, causing delays. The recommendation for a dedicated integration planning phase with clear roles is crucial for seamless coordinations, particularly with multiple parties involved. In scope management, Let identification of hidden scopes suggests a need for a more rigorous and thorough scope definition and validation process during the initial planning stages, potentially, pot- potentially including a dedicated scope identification phase for complex projects. Corrected scope indication is key in preventing late changes and cost escalations. Finally, working hour planning was insufficient, especially for critical path activities. The recommendation for more realistic and detailed working hour plans with allowance for flexibility and overtime while managing fatigue is vital for ensuring project timelines are met without compromising safety or efficiency.
Okay, let's go to the conclusion part. To conclude our presentation, let me briefly explain the planned shutdown project performed by TURCOMP based on the final close-out report. The shutdown was completed properly, one day ahead of schedule, showing great planning and time management. Most importantly, no lost time injuries have been recorded, demonstrating TURCOMP's high safety standard. The teams involved in the operation, including mechanical, scaffolding, cleaning, and inspection, performed effectively together. The report also note improved documentation quality, contractor and subcontractor cooperation, and overall project execution. However, several aspects can still be improved in the future shutdown, such as one is implementing digital workforce tracking system for real-time monitoring. Two is providing more hands-on safety training for workers. And last point is creating a more balanced and flexible work schedule to reduce operational stress. In summary, TOCOM's shutdowns project is a strong example of how critical operation can be complete safely, efficiently, and professionally when supported by disciplined planning and effective teamwork. Thank you for your attention.